Hi, my name is Lokesh Nandakumar Bhanashari, and we are going to start with the first subject as automata theory. Automata theory, or the theory of computer science, we can call it. So the first topic which we are going to start is FSM. So FSM consists of 4 parts: DFA, NFA, Moore and Mealy. You have heard of these 4 parts, but you have never heard of FSM, right? So we're going to learn FSM, because once we learn FSM, we'll get a clear idea of what DFA, NFA, Moore, Mealy have in common. So we will learn FSM and then we'll go on to these 4 parts. Okay, so let's just introduce these 4 parts. So FSM consists of 2 subparts. One is the FSM with final state and without output, and one is FSM without final state and with output. And then in the first part we have DFA and NFA, and the second part we have Moore and Mealy. So we are going to learn DFA, NFA, Moore and Mealy in the further tutorials, but for now we are going to focus on FSM. Okay, so let's start with FSM. Okay, so moving forward, we got the definition of FSM and what FSM consists of. While we are solving the problems of FSM, what will it consist of? So let's start with the definition of FSM. So as FSM defines, it consists of finite set of states which alters on receiving the input from input set I to produce output from output set O. So let me break down. So FSM is a machine which has different states in it, which are finite, of course. So it will alter from one state to another, or it will go from one state to another once it receives an input from a finite set of inputs. Like we define that there will be 4 types of input. So if it receives from any kind of input, then it will alter from one state to another to produce an output. That output will also be defined earlier. Like there will be 3 types of output, and it will give only these 3 types of output. So again, we'll read the definition that FSM consists of finite set of states. It consists of states which will alter, which will go from one state to another when it receives input from input set I to produce an output from output set O. We got that, right? So ahead, the 2 main functions which we'll define in FSM are state transition function STF and machine function MAF. So what does state transition function say? State transition functions say that if you have a state and an input, then which next state to go will be set by state transition function. And machine function will say if you have a state and you have an input, which will be the output from the output set. So these are the 2 main functions of FSM. We'll be learning about them once we start solving the problems. Okay, so let's start with the first problem, that is to see if a decimal number is divisible by 3 or not. We are going to make an FSM that will help us to check if the decimal number is divisible by 3 or not. So we have wrote down the 2 main functions, a machine function and state transition function, which are here. So we have to fill them up with the number of states and the inputs. We'll write the states here and the inputs over here. Okay, so as you can see, our inputs are 0 to 9, as they have asked a decimal number divisibility. So it's from 0 to 9, and the output will be yes or no. Yes, input is divisible by 3. No, input is not divisible by 3. Okay, so then let's start with filling of the inputs. So what we have input as 0 to 9. So what we'll do is we'll divide this input by 3, and we'll check for what is the remainder, and according to that we will fill it up. Okay, so we divide the first number as 0 by 3, we get the remainder as 0, so we put it in the first group. We divide 1 by 3, we get 1 as the remainder, so we put it in the second group. We divide 2 by 3, we get 2 as the remainder, so we put it in the third group. You see here we are taking out the remainders, okay, and not the quotient. So moving on, we divide 3 by 3, the remainder is 0, so we put it in the first group. We divide 4 by 3, the remainder is 1, we put it in the second group. We divide 5 by 3, the remainder is 2, so we put it in the third group. Moving on, we divide 6 by 3, we get 0 as the remainder, so in the first group. We divide 7 by 3, we get 1 as the remainder, so in the second group. And we divide 8 by 3, we get 2 as the remainder, we put in the third group. And the last one, 9, we divide 9 by 3, we get 0 as the remainder, so we put it in the first group. Now once we are done with this, we will write off the states. So we will have one state which will go when we have 0 as the remainder. So in hint, I'll write 0 remainder, go to Q0. Next state will be 1 remainder. Remainder 1 go to Q1. Remainder 2 go to Q2. So now we have states and the inputs sorted out. So we'll go ahead and fill the table. We'll fill the state transition table. Like at the start, we get 0369 as the input. We get 0369 as the input. We divide it by 3, and what will be the remainder? The remainder will be 0. So we'll go to Q0. So I write here Q0. Next QS, we get 147 as the input. We get 147 as the input. We divide it by 3. What is the remainder? 1. So we go to Q1. So I write here Q1. 258, we divide it by 3. We get the remainder as 2. So we go to Q2. So I write here Q2. Now, at the Q0 stage, we already have 0 over here. And anyone from 0369 comes. So we'll write here 03 or 06 or 09. Anyone will divide it by 3. What will the remainder? 0. So we write here Q0. Similarly, 01, 04, 07, any one of these comes and we divide it by 3. We get the remainder as 0. We get the remainder as 1. So we write here Q1. Next, 258, any one of those guys comes, any one of 258 comes and we append 0 in front of it. So we have 05, 02, 08. We divide it by 3. The remainder is 2. So we write here Q2. Now, 1 is already been there. Like in earlier stage there was 0 already. Now 1 is there. So now any one of 0369 comes, we write here 0 or we write here 3 or we write here 6. Any one of these comes, we append it with 1 and then what the number is? It's 16. So we divide 16 by 3. So once we divide 16 by 3, what is the remainder? 1, right? So we write here Q1. So we divide 16 by 3 or 19 by 3 or 13 by 3 or 10 by 3 and then what is the remainder? It's 1. So we write here Q1. Next, for next loop 147, we divide, 1 is already been there, so we get here 1 or we can write here 4 or we can write here 7 and then we divide it by 3. So when we divide 147, we get here 147 and we divide it by 3, we get 2 as the remainder. So it's like 11, 14 or 17, we divide it by 3, we get 2 as the remainder. So we write here Q2. Next, 258, any one of these guys comes, so we write here 2 or we write here 5 or we write here 8. Those are all the perfect divisibles, so we get remainder as 0, so we write here Q0. Now, the 2 is already been there, like earlier it was 1, now it's 2. So 20, 23, 26, 29, any one of these comes, say 26 is there, we divide it by 3 and whatever the remainder we get, that is 2. So we write here Q2. Next, 21, 24, 27, they are the perfect divisible, 21, 24, 27, so we write here Q0. And 22, 25, 28, when we divide them by 3, we get 1 as the remainder, so we write here Q1. So we are done with the state function. Now the machine function will be exactly the same except for these parts. The things that we have to fill in over here will be different. Those will be the inputs, okay? So we'll just write the states and the inputs same. Q0, Q1, Q2. And inputs as 0, 3, 6, 9, 1, 4, 7, 2, 5, 8. Okay. And we have to mark a final state over here. So we will mark Q0 as final. Why? Because we have to check if the number is divisible by 3 or not. And when is the number divisible by 3? When the remainder is 0. And when is the remainder 0? When we go to Q0. So we have to mark Q0 as the final state. Okay, so here also Q0 will be the final state. So in here, wherever Q0 appears, we'll write here yes. And for the rest of the part, we write no. Because when Q0 comes, the input number is divisible by 3. If we don't go to Q0, that is, if the remainder is not 0, then the decimal number that is coming as the input is not divisible by 3. So this is how we make a finite state machine the state function and the machine function. After this we are going to do a state transition diagram, okay, that will be explained. So after this we'll draw a state transition diagram. So a state transition diagram looks something like this. Okay, so state transition diagram, we start it with the states we have as Qs to Q2. So we'll draw 4 circles, one for each state, starting from Qs, Q0, Q1 and Q2. And then for Qs at its start state, we put in the arrow for start state. Q0 is the final state, so we double circle it. Okay, so we're done. So now we'll draw the edges. So arrows, we will draw the arrows here. Okay, so from Qs we go to Q0 when 0369 comes. So from Qs we're going to Q0 when 0369 comes, and the output that we give is yes. You see here we write output as yes, so a yes / yes. Next from Qs we go to Q1 when 147 comes. So Qs we go to Q1 when 147 comes, and the output will be no. Then from Qs we go to Q2 when 258 comes. So Qs we go to Q2 when 258 comes, and the output that we give is no. So like this we will draw from each state to each other state, okay, so that we can complete this diagram. Okay, so like this we draw the state transition diagram, and this is the completed state transition diagram. As you can see, there are arrows from each state going to each other state on every single input, that is the 03691 and the 147 and 2581. So this is the complete state transition diagram. So this all we do in FSM. We make a state transition function, we make a machine function, and we make a state transition diagram. Okay, so if you like this video, hit the like button. If you want to know about the latest and coming videos, hit the subscribe button and comment down with all the doubts that you have. I will love to solve it in the upcoming videos. Thank you for watching. Bye bye.